Okay, so today we're going to be talking about how to use math operators inside of our programs. So we're going to start out by creating a new class, and let's see here, it didn't fill out my source folder, so we're going to go math and logic. Okay, and then we're going to call this using math operators. And we want this thing to have a main method. Okay, so using math operators is the name of the class. Make sure that it has a main method, and then you can finish, and we should get something looking like that. And so we're just going to get rid of those right there. So the simple math operators are plus, minus, times is the asterisk, okay? Slash is for divide, okay? There's another one. Called modulus. Percent is the modulus operator. And that gives us the remainder after division. Okay, so we'll talk about that in a little more length in a second here. But let's just kind of talk about how to use math operators. So let's start out with some variables here. We're going to create some ints. So let's create x equal to 31, y equal to 12, and z equal to, I don't know, 5. Okay? So then let's continue on with this and say that we have a new x that's called apples, okay? And apples is going to be equal to x plus z, all right? And then let's print out apples. Okay, so this is pretty simple here, but hopefully what you're understanding is it's going to take 31, okay, plus 5, so we get 36 there, and it's going to store the result 36 into apples. So when we print it out, or when I run this, we see that 36 is what gets printed out. Any questions about that? All right, so that's pretty straightforward there, okay? Another thing that we can do, and this is a pretty common thing in programming, is we can take a variable that we already have and say, I want to take that and I want to add something onto it. So the way that we usually would do that is doing something like apples equals apples plus another value, okay? And so what this does is, you got to understand that it figures out the result of the right side of the equal sign and then takes that result and stores it back into apples, okay? So apples right now is 36. We're going to take 36, we're going to add the value of y, which is 12 from up here, so that should be 48, and that is going to be our new value of apples. So just print that out just to confirm it. Okay, and so now we have the original value of apples is 36, now the new value of apples is 48. Is that making sense so far? Okay, okay. So we can do some other stuff with it, right? We can say like int bananas equals apples divided by y, or divided by some other number. Okay, so let's say it's divided by 4. Okay, bananas equals apples divided by 4. Oh, I'm going to print that out, so let's do system.out. Okay, and so we get bananas is equal to 12. Okay, so that's taking the 48 value that we had just a second ago, dividing it by 4. We get 48 divided by 4 is 12. That value is stored in bananas, and now we're printing out bananas. You guys good so far? Okay, so there's a little bit of a weird thing that happens with integer division. Okay, so when we say integer division, we're saying we're taking an int and we're dividing it by another int. So what happens when that's not like a whole number result? Okay, so for example, here we have bananas is equal to 12. Okay, let's go ahead and say that we want bananas to now equal whatever apples was, which was 48. And let's divide that by 7. Okay. So this value is still 48. Okay. We're dividing 48 by 7. Okay. So 7 goes into 42 evenly, and it goes into 49 equally. So that means that this value should be something like 6 point something, right? Does that make sense? Okay. What's that? Okay, so we're saying that 48 divided by 7 should be some 6 point something. Okay, so the problem with that is if I print out bananas, okay? So if I print out bananas one more time, we said it should be 6 point something. All right?
It just say 6.
It's just going to say 6. So the issue here is that bananas is an int, apples is an int, and 7 is an int. And so if I'm taking an int and dividing it by an int, my only result can be an int. All right? Can only be a whole number. And so what it does, so right now we know that bananas equals 6. Okay? Because when we divide ints, any fractional result gets ignored, basically. Okay? All right? The technical term for that is it gets truncated, which means it just gets cut off. Okay? It's like the computer can't even manage it, so it just like ignores it. Okay? So the fractional part gets cut off, basically. It gets truncated. All right? So that's different if we're talking about doubles, okay? So if we have some double values like, I don't know, A equal to 45.2, B equal to 2.7, and C equal to 1,234.987. Okay? You don't have to have the same numbers as me, it's fine. So anyway, if we do something like double, I don't know, P equal to C divided by B, okay? So this is a fractional value, a double. This is a fractional value, B is a double. So the result of this will be a double, and that means I can store that into a double, okay? And so if we print out P, all right, I have no idea what that is. Okay, turns out it's 457 point bunch of decimal place numbers. Okay, so hopefully that's making some sense to you as far as like the difference between dividing two ints and the difference and dividing two doubles. Okay, it turns out, just as so you guys kind of get the full feeling for this, it turns out that we can take like we can create a double, and let's just call this thing R, and we can say that R equals apples divided by 7, just like we said bananas equals apples divided by 7 up here. Okay, but it's a little bit weird. Okay, so if I print out R, now let's see, apple, this was 6 point something, right? We expect that this would be like, I don't know, 6.8 something. Okay, I don't know exactly what it is. All right, so what happens is it actually gets the value 6.0. Okay, because what it does is it does the integer division. Okay, then stores the result, and the result of the integer division we saw before was 6 in the double, so it stores the result in the double, and let's just say stores the result, which is 6, sorry, in the double. All right, and then what happens is it's called promotion. Okay, then 6 gets promoted to 6.0. Okay, so we're assuming that doubles are a little bit better than integers, so that's why it's called promotion. Okay, so we're promoting the value 6 to the double value 6, which is just 6.0. Okay, so some technical stuff there, but hopefully that kind of makes sense to you, and as you see more of it, you kind of get familiar with it, and it's just a difference between, in a math class or a science class, you would always keep the fraction with you. In computer science, you have to remember that we're dealing with a computer and it's only storing a certain type of value when it does the math. Okay, so if it's only storing ints, then you're only going to get a whole number back. All right, so let's talk about some other things here. Let's talk about order of operations. So let's go back and say int, let's go back to some fruit here, so let's go pair, or pairs equals, and let's say that pairs equals, let's say 3 times the number of apples minus 5, okay? So like we got to take apples minus 5, and then we have to multiply that by 3, all right? So we want to do some order of operations things here. We're going to write an expression that does what we just said. So we're going to go 3 times, and then we said we have to take the number of apples, and we have to subtract 5 from it. Okay? So one thing that you should notice here is you can't do, look up at the screen for a second, okay? You can't do 3 times apples minus 5 like you could in a math class, okay? The computer doesn't know, it can't like decipher that you want to do multiplication there, so you have to be very explicit about what you're expecting it to do. So I'm just showing you here that you can group things together with parentheses, and then it's going to do the order of operations the way that you would expect it to do it, okay? So I don't even remember what apples is anymore, so what is apples, 12? No. Apples is 6, right? So this is going to be 6 minus 5 is 1, times 3 would be 3, right? So if we print out pairs, if I did my math right there, oh, I totally screwed that up. Apples is some bigger number. I don't remember what it was, but basically you get the idea here that, so it must have been 43, okay? No, it must have been 48. So 48 minus 5 is 43. 43 times 3 is 129. And so that's where we're getting this 129 number for pairs. Is that making sense to you guys? Okay, so we can write expressions like this inside of our programs. Okay, all right. So the last thing that we want to talk about then is this new operator called modulus. Okay, so modulus gives us the remainder after we do division. Okay, so let's just go through some examples here. We're going to talk about int. Mangoes like it. I like it. Int mangoes equals, and we're going to say, like, basically we're going to say if you take, let's say that we have 34 mangoes, okay, and we want to figure out if we have like a group of 8 people and we want to know how many mangoes are going to be left over after we give everybody a mango, okay? So the way that we would figure out how many mangoes each person gets if we had 8 people that we wanted to hand mangoes out to is we would say, well, everyone gets mangoes divided by 8. Right? So there's 8 people. Okay, so another way that we could do this is we could say int people equals 8. If you want to think about it that way, each person gets mangoes divided by people. Is that idea making sense so far? Okay, so let's print out each person gets each person. All right. So we got a bunch of other stuff there. Each person gets 4 mangoes. All right. And then let's say we wanted the computer to figure out how many mangoes we have left over. Okay. So the leftover operator is that modulus operator, basically. So we're going to say int leftover equals how many mangoes we have modulus people. Okay. So I'll print out with, sorry. Let me minimize that so you guys can see what I'm doing here. Alright, so if we print that out, if we run this, now we get each person gets 4 with 2 leftover mangoes. Alright, so what this is doing, what this modulus operator is doing, is it's figuring out 34 divided by 8 is whatever it is, and then we have 2 left over. So each person is 4, 34 divided by 8, right? It truncates the leftover stuff, okay? This figures out what that leftover stuff was that got truncated. So it's kind of like doing long division, all right? It's like doing long division. And then remember when you first learned how to do long division, you did all the stuff and then you said remainder something, okay? So that something is the thing that we're getting with this modulus operator, okay? So what I want to do right now is just run this a couple more times, but change the number of mangoes so that you start to understand what's going on, okay? So we're going to go, what if it's 35 mangoes? Okay, now each person gets 4 with 3 leftover mangoes, right? 8 goes into 32 evenly. 35 is 3 more than 32, okay? What if it's 36? Okay, each person gets 4 mangoes with 4 left over. Is that making sense for everybody? Okay, so what if I change this number? What if the number of people changes, and let's say now that there's 5 people, okay? What do you think this is going to print out? If it's 36 mangoes and there's 5 people, each person is going to get how many mangoes? 7 mangoes, right? Because 5 goes into 35 7 times, right? Okay, and how many are going to be left over? 1. Okay, good. Okay, so that's how modulus works. It gives us the remainder value.